Hello, in this project I work on a fantasy-themed RPG dataset containing information about characters including combat abilities, magical power, race, guild, affiliation, territory, and class. The goal of this project was to build a machine learning classification model that predicts a character class based on its attribute. To achieve this, I cleaned the data, explored patterns through the visualization, selected the most important features, trained multiple models, and evaluated their performance. Sample row of the dataset. After that, I show some shape of the dataset and information of the dataset, and also describes all of the dataset. Also show column of the dataset. After that, I checked for missing value and also check the missing value percentage of this data set. And after checking the missing value, I handle the missing value with using mean, while missing categorical values are filled with the most frequent categorical. After the handling the missing value, I check the database, is there any missing value is remaining in the dataset. After that, I also corrected incorrect categorical entities such as unknown or question mark by replacing them with the mode of the column. After that, I detect and remove the outlier with IQR method. Instead of removing rows, I kept with the extreme value so the dataset remained intact with the minimizing the effect of outlier. Finally, I standardized the numerical variable using a standard scalar so that all features are on the same scale before training the machine learning model. After completing the data pre-processing step, I performed exploratory data analysis to better understand the dataset and identify patterns that could affect model performance. First, I visualized the distribution of the numerical feature using the histogram. The histogram shows that many of the variables are not normally performed and distributed. Some features are skewed and other has a long tail which indicated presence and extremes value. These confirm the needed for scaling and outlier treatment during the pre-processing. Next, I use box plot for outlier detection. The box plot shows that several variables contains extreme value outside the normal range. These outliers could distort performance that machine learning models. So they are kept during the pre-processing stage using the IQR method. I also use scatter plot for feature relationship. The scatter plot shows that the points are widely dispersed, indicated weak relationship between many of the variables. This is suggested that the feature may independently contribute to predict the target classes rather than having a strong linear relationship. To analyze the correlation between features, I generate the correlation heat map. In this heat map, it shows that the most correlation between numerical are relatively weak with a few relationship that indicated no single feature strongly explained with the other, and the dataset contains complex relationship. To identify important versus irrelevant feature using the statistic test or feature importance. This allow me to rank a feature based on their contributions to predict the targeted class. Feature with the higher importance scores are considered more relevant, and while features with a very low score are treated as less useful or noisy variable. I visualize the most important features. Also, I investigated the class imbalance by plotting the distribution of the targeting variable, which is the character classes. So in this part just shows the distribution of the character classes, the data set. So there is no overwhelming or dominating in this data set. So Overall, the exploratory data analysis shows that the dataset contains skew distribution, weak correlation, and overlapping feature patterns, which suggested that predicting characters class may be challenging. After completing the exploratory data analysis, I performed feature selection and feature engineering to identify the most relevant variable to predicting the character score. First, I choose the random forest feature importance and showing the most important feature of this database. Also visualize the top 10 important feature. To compare the different feature, I selection three methods. First, I selected the feature based selection method. In this feature based selection method, feature wires ranked on statistical importance score and top ranked feature were selected. This approach is fast, easy to apply. It evaluates each feature independently and does not consider interaction between the variables. Next, I apply a rep-based selection method. So in this selection method, ranks the feature, removes the at least important ones until the desired number of the feature remain. These methods often provide the better feature selection than filter method because it considers model performance, but it requires more time. After that, I use the embedded method feature selection based on the random forest feature importance. Random forest calculate the importance score based on the how much feature contributed to reducing the classification method. This method is capture nonlinear relationship and interaction between variables, making it effective for identifier importance. After comparing the three methods, I selected embedded method because it provided meaningful importance ranking while remaining computationally and efficiency. The most important feature are retained for this model. Also, I shows the top 10 features of this embedded method. After selecting this relevant feature, I applied dimensionality reduction technique. I show the PCA visualization. In this PCA capture the maximum variance in the data that helps visualize whether the character classes from distinct group. The PCA plots shows that the classes overlapped heavily with no clear separation between the groups. This suggested that the selected features do not clearly distinguish the character classes. I then used the TSNE plot. The TSNE plot also shows the overlapping clustering, although some small groups are visible. However, there is no still strong separation among these classes. This class indicated that the dataset contained overlapping feature patterns, which makes classification difficult. Overall, feature selection helped to identify the most informative variables, while PCA and TSNE revealed that the character classes are not clearly separated the feature space. Selecting the most relevant feature, I trained the multiple classification model to predict the character classes. So first of the classification model, I split the data and the testing set. The testing set was used to train the model, while the testing set was used to evaluate their performance and unseen the data. I'm using the random forest model, and also I evaluated the accuracy, precision, and recall, and the F1. Accuracy measure the percentage of the accurate prediction, and precision measure how many predicted levels are incorrect, and recall measure how many actual level successfully identified. F1 scores provided a balance between the precision and the recall. So here also I find out the classification report among the accuracy, precision, recall, and the F1 score. After the initial evaluation, I optimized the best performance model using the hyperparameter tuning. I use the guard-based search to test the multiple combination of the random forest parameters, such as the number of the trees, tree depth, and minimum the sample per split. Hyperparameter tuning helps to identify the best settings for improving the model performance. After the tuning improves slightly, but the overall accuracy remains low. This indicated that the main limitation is not the model itself, but its structure, the data. To better understanding the variable influenced the prediction, and I analyze the feature importance score from the random forest model. Some attributes contributed more strongly to predicting character classes, while the other had a very low importance. Overall, random forest performed best, but low accuracy indicated that the classes are not well separated in the dataset. As an additional step, I also do the multiple models. Some of them are decision tree, logistic regression, and the random forest. First, I compare the multiple classification model using the decision tree, logistic regression, and the random. The comparisons allow to visualize the model performance, how the model is working among the model. A random forest achieve the highest accuracy and the F1 scores. Next, I apply the assemble technique to determine whether the combining multiple models improving their performance. I use the bagging and boosting here, and also compare the methods. So in the visualization, I saw that the random forest is higher among the banking and boosting methods. So in this visualization, we say there's random forest achieve the best performance among them. So after that, I using the cluster algorithm. I apply the k-means and also visualize the PCA clustering. So in this cluster, identify the natural among data we using without using the target variable. The clustering result shows the overlapping groups rather than the clearly separated clusters. Overall, these analysis confirm that although more advanced methods were tested, the dataset structure remained the main changes. The overlap main among the classes weak, feature separatively limited, and the ability for both classification and clustering algorithm to perform well. Main challenges in this project are handling the messy data, selective relevant feature, and dealing with the overlapping classes. The dataset contain missing value, outlier, and the noisy variable, which require extensive pre-processing. Even after featuring selection, model tuning, the class were still high overlapping, as shown as the PCA and TSNA plots. These weak class separatively made accurate classification difficult and limited the performance of this model. Thank you.